Yes, I'm Pete Worden. I'm the Executive Director of Breakthrough Initiatives and the Chairman of the Breakthrough Prize Foundation. I have a long career in space and space science. I spent 29 years as a U.S. Air Force space officer and uh, spent a few years as a college professor, and then spent 9 years as the director of NASA's Ames Research Center. And then for
Oh,
the last 10 years, I've been involved in philanthropic space efforts.
okay. So speaking of the breakthrough, so what is the current status of it, and like what are some of the challenges that you face with it right now?
Well, we Breakthrough Initiatives is all about finding life in the universe. And we had uh, three major directions. The first one was looking for any evidence of life, and that we called Breakthrough Watch. The second one, actually the largest one, is Breakthrough Listen, which is to look for what are called technosignatures, evidence of an alien technological civilization. The third one was figuring out if there's possibilities of traveling interstellar distances. I mean, sending probes, for example.
Mhm.
Uh, that was called Breakthrough Starshot. Now, the third one is sort of been put on hold. I think our sponsor is skeptical that it's affordable and doable this century. I may differ with him, but it's his money. And but we also have an annual conference, which we held this last year and or this year in Oxford University, where that's where our largest program, the Breakthrough Listen technosignature effort is. So that's basically the what we do at Breakthrough Initiatives. I'm also I mentioned the chairman of the Breakthrough Prize Foundation. The Breakthrough Prize Foundation was started about 20 years ago, and or 25 years ago. It's the world's largest science prizes. We give $3 million prizes in life sciences, fundamental physics, and mathematics. We also have early career prizes, and one of the most exciting things we have for high school students is the Breakthrough Junior Challenge, which is an effort we ask people to do a short video, and the winner gets a $250,000 scholarship wherever they want to go. They get to appear at the Breakthrough Prize ceremony, which is in Hollywood. It's kind of a neat. We call it the Oscars of Science, and in fact has a lot of real Oscar winners there. And then the school gets a $150,000 laboratory, and the teacher that inspired the student gets a $50,000 check. So it's kind of cool.
Wow, that's pretty crazy. But speaking of sending probes, what do you think the timeline looks like for humanity sending probes to other star systems?
Well, that's a good question. I mean, we had hoped that when we started this program that it might be possible by the middle of the century. I think that the technology is probably more like near the end of the century, but there could always be breakthroughs. The approach we were using was to take a really small spacecraft that's a matter of grams that had a sort of a gossamer light sail that was made out of some exotic material. And then you hit it from with a laser on the ground that has 100 gigawatts of power. So it's you know, 1,000 times more powerful than lasers that we build today. And it pushes it up to 20% the speed of light. And then, of course, the nearest star system is a little over 4 light years away. So it takes about uh, 20 years or so to get there. And so that looks actually pretty promising in the long run. There's a lot of developments that need to be done in making the lasers cheaper and constructing them. But I think that, we showed that it was feasible, but it isn't so near term. So, there is funding going into it now by a number of sources. So I think it'll eventually happen. Now, there may be other ways to get there as well.
Yeah.
And but uh, but that's what we were looking at, the Breakthrough Starshot approach.
Okay, so I know you did a lot of work on small satellites, especially since you were like the director of the Ames Research Center. So how do you see the role of these small satellites evolving over the next 10 to 15 years?
Well, it's a very interesting question. I became a kind of an advocate of small satellites a long time ago. In the 89 to 91, I worked at the White House at the National Space Council for the first Bush administration, and we were confronted with a very expensive system called the Earth Observing System, which was very large satellites to observe the Earth. And we were convinced that the technology was coming along that you didn't have to spend that much money. And we had developed some concepts for cheaper satellites. A lot of these were based on what is known popularly as the Star Wars program. That was the program in the 1980s that I guess it's restarting again as the Golden Dome effort. And there we developed really small satellites, small cheap satellites. And in the 90s, people started to develop CubeSats that were, 1 kilogram, 10 centimeter square satellites. And so when I was at Ames, the NASA centers are fairly competitive.
Yeah.
And I said, well, if you want to be competitive, do something that your competitors aren't doing. So we started to look at small, cheap satellites and see what we could do. Probably the most impressive program was done by a couple of my young people. That my chief engineer, who wasn't young, by the way, used to like to hold up his cell phone, and
Mhm.
he'd say, look, this thing has everything in it that a satellite does. It's got communications, it's got direction, it's got instruments, and he said it cost a few $100s. And why can't you build satellites that cost a few $100s using commercial stuff? And a couple of the sort of visionary younger people on the staff said, okay. So they started a program called PhoneSat.
Mm.
And so I didn't pay much attention to what they were doing, but they eventually they took these phones and put them in a CubeSat, and then they got them launched from the space shuttle. And it was or the space station. And it turned out to be an impressive program. They all worked. And now the guys that did that started this company called Planet, which now has, almost 1,000 satellites in orbit that observe the Earth every day. Some of them are CubeSats, some of them are a little bigger. And so it was kind of a neat effort. What was kind of funny, we just launched these and nobody knew much about them. And that was when President Obama was president, and he used to come to Silicon Valley occasionally. And my job as the director at NASA Ames was when Air Force One landed, I'd go out to the airfield and greet him. I said I was Peter the Greeter. And he'd always would say the same thing. He would say, "Oh, we're really proud of what you're doing at NASA," but I really wanted to show him what we're doing. And so the last time he came there, I said, "Mr. President, welcome to NASA Ames, where we just launched the world's cheapest satellites." And he stopped and said, "Well, how cheap were they?" And I said, "Well, they were two of them were $4,000 and one was $10,000." And without missing a beat, the president looks at me and he says, "We're giving you guys at NASA too much money," and then walked on. Later, the NASA administrator asked me, "Well, what did the president talk to you about?" He said, he told us that we're doing a great job. So I didn't want to, but at any rate, that's kind of where I think we had a number of people doing things with CubeSats and small sats, and a lot of them went off and started companies.
Yeah. Okay. Well, do you think that we'll see any more deep space missions using these small sats or not anytime soon?
Well, there's been a couple. I mean, they haven't been very successful to go, beyond Earth orbit. And a lot of it is that, it's harder to get beyond Earth orbit. But I think there's very likely to be deep space missions using CubeSat technology. In fact, I'm involved with a startup that I've been helping that's looking at using, CubeSats and small sats in cislunar space. So there's a lot of possibilities of uh, of doing, I think CubeSats in deeper space. I mean, they have sent CubeSats to Mars and other things, and some of them worked.
Okay. Yeah. Well, I mean, but aside from CubeSats, is there like a project or certain innovation or even a private space that really excites you?
Well, I think there's a lot of things. we're at the verge of having permanent human settlements on the moon and Mars.
Yes.
And I've always been very excited about that. So one of the things that I'm very interested in is uh, in order to live on the moon and Mars, you probably need advanced technology. So one of the things that people always say, well, if you live in another world, you want a programmable self-replicating machine. Well, we have that. That's called biology. So I've always been very excited about using biology to modify it to help live in other worlds. So, when I was at NASA Ames, we started a synthetic biology program, and now there's a lot of enthusiasm for that. I think particularly with the idea of terraforming Mars. So that's an area that excites me. The other one is really science. Uh, one of the things that the Starshot and the Breakthrough Watch program is I was looking for is there uh, life-bearing planets in other star systems? Uh, as a scientist, that's always been my number one interest, and and I think we're at the verge of detecting that. And uh, and in fact, one of the things that Breakthrough Watch did a few years ago is we found tentative evidence of a giant planet orbiting in the habitable zone of Alpha Centauri A, which is the next nearest star system. It's the biggest star of the three in that system, and it's a little bit bigger than the sun. Well, the interesting thing about giant planets orbiting Alpha Centauri A is that was the scenario in the Avatar movies, that there's a giant planet orbiting Alpha Centauri A in the habitable zone, and it has moons that are inhabited. Uh, so one of the things that I'm very excited about is really finding planets or even moons orbiting the nearby stars. And there's a number of programs that both Breakthrough and other foundations are doing that. So on a science thing, I think we'll
Okay.
probably find a life-bearing planet nearby.
Yeah. So you mentioned that we're on the verge of settlement on Mars, but what role do you think international collaboration between agencies will play in this next era of space exploration?
Well, I think that obviously there's a lot of discussion, in the United States and elsewhere of how much is done, you know, in just one country versus others. I mean, I'm speaking to you today from Luxembourg,
Wow.
and about a decade ago, I was involved in helping set up the Luxembourg Space Agency, which is
Okay.
a very dynamic program. It's really a commercial investment agency. There's almost 100 startups now in Luxembourg. And one of the things they're looking at is space resources. So, I think that internationally there's a lot of expertise. Right now, I'm working with in Germany. There's a program that the German government has that's sort of like the U.S. DARPA, and they're looking seriously at programs like Mars terraforming. So you hear more about that soon, I think. So there's a lot of international efforts. Uh, to be sure, in my opinion, that the U.S. has got a lot of really smart people, but so does a lot of other places do as well. So I think that the effort to settle the moon and Mars is certainly going to be a global effort.
Oh yeah. So you mentioned that there's a lot of startups in Luxembourg. So like how can we make sure that space remains like peaceful as more and more countries and even the startups could get involved?
Well, I mentioned I was a military guy. I'm a retired brigadier general, and
Yes.
I think that there's a combination of things. It's just like in the oceans.
Okay.
First of all, you have agreements and rules of the road and I think we need more of those to just agreements to say, look, don't get this close to another satellite, don't do anything threatening, and also agreements about how we use resources on the moon and other places, and there's efforts going on to get agreements. But the second thing is you need some way to enforce those. And I think that just like on the sea, I mean, there isn't a global navy, but there's lots of different countries have navies, and the navies work with each other. And so they suppress things like piracy and help enforce things. So I think a combination of of having, things like the U.S. Space Force, and
Yeah.
there's now the French government has a Space Force, other countries do as well. That that the idea of those are to not to fight wars as much as they are to keep the peace. So those
Okay.
two things I think are necessary. Is a is a is a way to uh, agreements to make sure people know how to behave, and as well as is a security force that helps enforce them.
Okay. Well, do you think that there's like a need to have more strict global agreements or even like a governing model for space?
Well, no, actually, I think there needs to be more what I call rules of the road agreements.
Okay.
That these are like protocols to the Outer Space Treaty, and a good example of one is, as we start doing, extracting resources of the moon like water. You need some rules written down that says, okay, if one group or a company or a country or groups of countries and companies have a claim at a certain place, that other people won't try to go steal it or
Yeah.
interfere with it. And so those are agreements. And right now there aren't agreements, but the same thing is really true in the ocean. If you're fishing someplace, there's fishing rules in the open ocean that says that you don't cut other people's nets or try to steal catches and so forth. So these aren't government organizations. I fear large bureaucracies that that they spend a lot of it costs a lot of money. They make lots of rules that may or may not make sense. A good example of where rules are done and enforced is the in radio frequency allocations. There's the World Radio Conference that it's not an official governing board. It's affiliated with the UN, but it's voluntary participation. And everybody realizes that by honoring slots and frequencies that have been agreed to, that everybody wins. So I'm skeptical of having, a global space agency. I mean, I think space agencies become bad bureaucracies.
Okay. Yeah. So generally, we like to finish the World of Aerospace like meetings that we have with some advice for young people. So I'd like to get your advice. So what advice do you have for high school or college students that are wanting to make an impact in space exploration?
Well, I have a lot of them, but
Yeah.
I think it would boil down is to pick something that you want to do
Okay.
that really excites you, that you wake up every morning and say, I can't wait to get to work. This is a dream I've had. I mean, I had a dream of doing interstellar, you know, studies and travel ever since I was about 6 years old.
Okay.
And so the first thing is don't do something just because it looks like it pays well or it puts you in a good position or your friends are doing it. It's that, when I get up in the morning, I really want to go to work because this is fun. Uh, the second thing I think is prepare yourself educationally. I mean, space is hard. It's a technical area. So I advocate people, study STEM skills, get graduate degrees, maybe even a doctorate. And it's hard. I mean, it's good things are always hard. Uh, the third one is not to be afraid of failure. And the key thing is that companies that succeed or people that succeed have had a lot of failures and don't get discouraged. That if you lose out on one thing, it'll open a door to something else. So those are the three things. Do what's fun, get the education, and don't be discouraged when everything doesn't work out the way you'd hoped.
Okay, so now talking about some careers, are there any like certain emerging fields or technologies that students that you would say are like more that are starting to become very important?
Yeah, I think I sort of alluded to one of them. Uh, if I was to start over again, I'd be very excited about biology and space. So I think studying uh, how life works, what is life? We don't even know what life is. and how we can use it in space is a very important field. I think that's, something that's going to grow immensely. Obviously related to that is, what is consciousness? We don't know, we're starting to look at AI and AGI. And so, trying to understand, two of the fundamental questions, what's life and what's consciousness, are areas I think are really going to be important.
Okay. Yeah, well, looking back on your career, what opportunities or like decisions do you think made the biggest difference and got you to where you are today?
Well, it's really a lot of them. I mean, to me, one of the most important things is I've always been lucky to have people that were older and successful that sort of were mentors. And throughout my career, these been mentors that have been really meant a lot, have helped me. I named just a few. One of them was Edward Teller, the inventor of the hydrogen bomb, and he helped me a lot. Another one is General Bernard Benny Schriever, who was the guy that built the U.S. ICBMs in the 1950s. He was a mentor and guide. Another one that I got to know and is sort of a philosophical guide is Arthur C. Clarke, the science fiction author. I got to meet with him a few times. So I think to me, the key thing is to find somebody that you admire and you admire their work. And most people are happy to help. And, it helps to have a senior person that has been there, has made mistakes and made successes, give you some advice and help. In one case, I was in consideration for a job at the White House. There were like 5 or 6 people. What got me the job was Edward Teller, who was knew President Bush and Reagan, and he called up and got me the job. So, it's always important to try to find somebody that you admire and get them to help.
Okay, okay, what new fields of space research should young people start paying attention to for the future?
Well, I mentioned biology and AI. Uh,
Yes,
a third one is probably propulsion, advanced propulsion. Uh,
like electric propulsion.
well, I'd say starting with that, but now, unfortunately, I think I just read that NASA had cut off the nuclear propulsion. I mean, I think nuclear propulsion is likely to work, but there may even be exotic physics, maybe things that
Yeah.
warp drives and so on. I mean, there's some interesting ideas. So I would say that's in addition to biology and AI, there should be uh, look at some of the propulsion technologies.
Yeah. Okay. Well,